Hi everyone and welcome back to Simplifinity. Have you ever wondered why did we use log-based tools sometimes in recurrence relations? Let's find out. So before that, let us quickly recall what logarithm or log means. Okay, so let's take a small example. Log base 2, 8 equals to 3, right? Yes, it is. If you reverse it, it means 2 to the power 3 equals to 8. So this is equal. But is it what this actually means? What is the meaning of this? This means, this means that if you divide 8 by 2, we get 4. Then we divide 4 by 2, we get 2. Then we divide 2 by 2. Why are we using 2? Because the base is 2, of course. Then we get 1. This is our goal. Okay. So if we have reached our goal, let us count how many steps did we do. 2 and this is 3. So in 3 steps, we got 1. Can you see the answer of this? It's 3. So can we say that the number of steps that is needed to get 1, like from 8 to 1, dividing 8 by 2 each time, like each time you are halving your input to reach 1, the number of steps is you are getting it through log. Okay. So now let us see this recurrence relation. You might have already seen this. So this is T of n equals to 2T of n by 2 plus C. You have already seen this, right? Yeah. So over here, do you remember what the time complexity comes? It basically comes in the terms of log, right? But we have a confusion with base. What is it? Log base 2, log base 10, or is it log base E? And if not log base 10 or E, why only log base 2? Because you see the answer right here. But why do we need to use log base 2? Because in binary search, these are algorithms, right? Binary search, merge sort, the divide and conquer algorithms, because we are studying DAA, so we are going to focus on algorithms. In these algorithms, did you notice one thing, that the input, which we take as n, it is getting halved each time until it becomes 1, or it becomes so small, or 1, close to 1 or 1, right? We are decreasing it. We are halving it in every step. Okay. So that is the thing. That is why we are using log base 2. And that is why we are not using log base 10. When I first learned about this thing, like we are taking log on both sides, right? There was a, let me just take another page. So when we had this n by 2 to the power k, we used to take this equals to 1 or a constant. So then n equals to would be 2 to the power k. Then we used to take log on both sides. So this becomes log n. This becomes log 2. And yeah, okay. So 2 to the power k. Right? Now, when I learned this first, my confusion was, now the answer would come like this. Equals to k, right? This was actually the answer and it was correct also. But why? Because generally we used to take log base 10 or log base e, right? So how is log base 10 2 equals to 1? How is it possible? Because we are actually taking log base 2 here. We are taking none of these. And why we are taking log base 2? because it is mentioned in the question. Okay, that is why we are taking log base 2. Okay, if it was like, if the recurrence relation was, this is a tip you can say, if the recurrence relation was something like this, okay, what would you have taken? Log base. Okay, that's your homework for today. Okay, find out and comment it, okay, that what are you going to take the base as. So I hope you understand why did we take log base 2 and not log base 10 or log base e, which we generally do. Why did we not do that in the recurrence relations? And this is your answer. If you have any doubts, comment it down and I'll solve it for you. Thank you so much. Keep supporting and give me a like, share this with your friends and comment. Thank you.